Hi class. This is question number 5 for learning outcome 3, learning step 3 for the review exercise on working with normal distributions that I'm going to put down in the link below. So this is really where we get into the word problems. Now that we know how to work with a standard normal distribution, and we know how to work with a normal distribution by converting back to a standard normal distribution, I want to take that knowledge, because that's all the math that's behind it, and sort of use it in a holistic way to actually solve some word problems. And that's going to help you out a lot in, if you're in my Stat 202 class, help you out a lot with your assignment. Okay, so again, if you look back on my assignment, or back on my videos, question 1 for standard normal distribution helps you solve question 3 for normal distributions, and then question 3 helps you solve, or at least do the math computational component of question 5. So here, let's take a look at let's read the question. So suppose the ages of individuals arrested for driving under the influence of drugs and or alcohol are approximately normally distributed, so that's the key that lets us use all this probability, with a mean mu equals 26 years and a standard deviation of sigma equals 3.2 years. So remember, when we were doing question 3, we always, and question 4, but this is going to be more relevant to question 3, or at least that the techniques will be more similar to question 3. We always had a population mean and a population standard deviation. And it's asking for what is the probability that the age of a person arrested for this offense is, and the first question is older than 35 years old. So a good way to start when you're thinking about these problems is try to identify what the random variable in question is, right? What is the thing that's determined randomly? Well, what is random is the ages of each of these people arrested. If you're a police officer and you're pulling people over and you're arresting them for drinking and driving, you're not really going to know, if you see their Chevy Cobalt driving, if that's going to be a teenager or a 35-year-old or a 45-year-old. You don't know. It's kind of random. So that part's decided randomly. So I would think that the X represents the age of the person arrested for drinking and driving. It's also hinted at in the question, right? I mean, what is the probability that the age of a person arrested for the offense is? Well, typically you're going to be putting the probability, and inside that you're going to have an X and some numbers. Well, older than 35, you'd imagine that would be your number, and your X, well, it would have to represent the age of a person arrested for the offense. So let's write this out mathematically. We need to know the probability that the age of a person arrested for this offense is older than 35 years old. So here's my probability. I'm just going to put brackets around it. And we need to know the probability that the age of a person arrested for drinking and driving is older than 35 years old. So writing that out mathematically, X is older or greater than 35 years old. That's what we're trying to figure out. Okay. And now remember, the way we do this is we convert everything to a z value using z equals x minus mu over sigma. Right? So let's convert everything to a z value, figure out the probability there. And then, so remember, this is equal to the probability that z is greater than, say, z1. Well, z1 is equal to this x1, which is 35, minus mu, which is 26, and then over sigma, which is 3.2. Here's my calculator. So I have 35 minus 26 divided by 3.2. This is going to give me 2.8125, but let's round to 2 decimal places because we're only going to need that to look up on the table. So this is the probability that z is greater than 2.81. Okay? Or in other words, remember when we draw this out, I won't put an equal sign. When we draw this out, we have Right? This is the probability that Z is greater than 2.81. So it's that region in there. Now remember, we always decided the way we'd figure this out is we figure out the probability of the whole thing is 0.5, and then we just take away this region in here. Well, this region in here is just the probability that Z is between 0 and 2.81. So the probability that Z is greater than 2.81 happens to be equal to 0.5 minus the probability that Z is between 0 and 2.81. Okay, so in other words, the probability that Z is greater than 2.81. Sometimes you'll see little deviations in how I do these things, slight differences between problem to problem, and this is just so that you can get comfortable with seeing these things. You know, trying to figure out what the important parts are and the stuff that can be kept, the stuff that can be removed. I'm not that picky about the work that you do. I just want to see that you do the work. So 2.81, 2.8, and 1. I get 0.4975. So that's minus 0.4975. Just figure that out. 0.5 minus 0.4975. Whoops. 0.5 minus 0.4975, and in the end it looks like what we get is the probability that Z is greater than 2.81 is just equal to 0.0025. Or in other words, because we agreed that the probability that Z is greater than 2.81 is the exact same as the probability that X, the variable we're interested in, is, or that the age of a person arrested for drinking and driving is older than 35 years old, well, that's the exact same as the probability that Z is greater than 2.81. So what we're saying then is the probability that X is greater than 35 happens to be equal to 0.0025. So it's not that likely that when you pull somebody over, they happen to be older than 35. So, all right, and the next question would be, well, I guess it's B. So this is the probability, or we want to know the probability that the age of a person arrested for this offense is younger than 18 years old. So hopefully there's not too many there, but let's see. So again, X is still the age of the person arrested, but now we need to represent younger than 18 mathematically. Well, if X is the age, and you need to be younger than 18 years old. And then you want to figure out the probability of that. So remember, this is equal to the probability that Z is less than Z1. You can skip this step too if you just want to take the next step and say, well, Z1 equals 18 minus 26 divided by 3.2. So in other words, this is equal to 18 minus 26 divided by 3.2. I get negative 2.5. Okay, so this is the probability that Z is less than negative 2.5. When we draw that out, pardon my awful drawing, there's my negative 2.5, and this is Z is less than negative 2.5. So remember, same thing as the last question. The whole thing, the whole bottom side is 0.5. That's the probability that you're less than 0 when you're dealing with the Z distribution. And we need to take away just this region below that. So, just like before, we have the probability that Z is less than negative 2.5 is equal to 0.5 minus the probability that negative 2.5, or that Z is between negative 2.5 and 0. Okay, so the probability Z is less than negative 2.5 is equal to 0.5. I'm just going to save myself some time with this. And we got to look this up. So 2.5 and 0, we look for it. Negative 2.5, well, 2.5, and then there's nothing in the second digit, 0.4938. Oh, where the heck? 0.4938. All right, so the probability that z is less than negative 2.5 is equal to 0.5 minus 0.4938, which I'm getting 0.0062, or in other words, the probability that x is less than 18, because we know that this is equal to the probability that x is less than 18, is equal to 0.0062. So in both cases, the probability you're older than 35 or the probability you're less than 18 are actually less than 1%. So that kind of lines up with intuition, right? You'd expect that people younger than 18 are not drinking and driving, or at least they don't get caught. And you'd also expect the same thing of people older than 35. You figure you'd have it together by that point in your life. All right, 3.4 review. We're going to do 5C. So now it's asking, what is the age, or what's the probability the age of the person arrested for this offense is now between 19 and 24. So now we model it. We say, well, now x should be sandwiched between 19 and 24. So I should have a 19 here, and x should be bigger than 19, but it should also be less than 24. So probability. All right, and so from here, what do we want to figure out? Well, we have to figure out two z's, right? This is equal to the probability z1, which we don't know yet, or that z's between z1 and z2. So let's figure that out. z1 is going to be equal to 19. Oh, and let's not forget, mu here is equal to 26 years, and sigma is actually equal to 3.2. Okay. Let's see. So this is 19 minus 26 divided by 3.2. So we have 19 minus 26 divided by 3.2. So I get negative 2.19. Okay. Now I don't actively check my answers along with this. So, you know, I might make a mistake. You never know, and I upload these pretty rapidly, so sometimes I may miss it. But if you do see a mistake, don't be afraid to point it out to me. I'll try to issue a correction. But more than anything, the important thing is that you're following the process that I'm following. That's kind of what's important, not so much what the final answer is. I mean, yes, it's important to find the final answer. This should be 6.3 because I round up, by the way. It's not, but you know, it's more important to follow my process than it is to necessarily get exactly the right, correct answer. And if you are in my class, I tend to give quite good marks for good work, right? So even if you get the question wrong, I still try my best to give you quite a lot of marks if your process was mostly the correct. Okay, so I've made all these number changes and I've put them all in. And now we have to try to figure out, well, what's that region? Okay, well, draw my bell curve. I have one down here. This is negative 2.19. And I have one up here, which is negative 0.63. So I'm trying to find that region in there. So again, when we're dealing with a question like this, where we've got a little slice on one side of the graph, it's up to us to figure out the entire region and just subtract off the little bit that we don't want. So, probability that z is between 2.19 and negative 0.63 happens to be equal to the probability that z is between negative 2.19 and 0 minus, I did it backwards, but no problem. The probability that Z is between negative 0.63 and 0. Okay, so this should be equal to, and we can look these things up on our chart, 2.19, let's just look here, 2.1, and then where's my 9? Right there, 0.4857, 0.4857 minus, and 0.63, where's that 0.63? 0.6 and 3. 2357, 0.2357. So the probability that negative 2.19 is less than Z is less than negative 0.63 happens to be, let's just figure this out. It's getting towards the end of the workday. My brain's getting pretty fried, so can't do these in my head. 0.2357. I'm not sure I could have done them in my head, at least quickly to begin with. Some mathematician I am. Okay, so 0.25 is what this should be equal to, and let's just remember that this is equal to this, so the probability that the age is between 19 and 24 happens to be equal to 25%. Okay, so yeah, so we looks like most of the drunk drivers are between 25 and 30. So let's figure that out. That's kind of my guess, but the last question happens to resolve that question for us. Between 25 and 30. Okay. So between 25 and 30, same thing. Probability that we're between 25 x and 30. Okay, and we're missing a few things with this data. Anybody who's between 25 and 24 is kind of being excluded by the way that we've built this, by the way, and anybody who's between 19 and 18 is also excluded. So there might be some people in there that we're missing, but this is what it is at. This is what the questions are asking, so we'll try to stick to that. So same thing as last time. The probability that Z's between Z1 and Z2. Okay. Well, Z1 is equal to 25 minus 26 over 3.2. So 25 minus 26 divided by 3.2 is going to be equal to negative 0.3125. And then Z2, this is equal to 30 minus 26 over 3.2. 30 minus 26 divided by 3.2. This is going to be equal to 1.25. So this is equal to the probability that Z is between negative, oh, and by the way, I should round that to 2 decimal places, 0.331. So that Z is between negative 0.31 and positive 1.25. Okay. If I were to graph this, which we should always try to do, again, you're always going to get marks if you're in my class for graphing these things. Well, this is a negative number, so it's going to live down here, 0.31, negative. And this is a positive number, so it's going to be up here, 1.25. And remember, when we're trying to figure out this whole thing, we take the stuff up top, or make it the opposite direction here, and the stuff on the bottom, or the stuff in the positive side and the stuff on the negative side, and we're going to add those two together. So this is all, so the probability that Z is between negative 0.31 and 1.25 happens to be equal to the probability that negative 0.31, or this Z is between 0.31 and 0, plus, so we add the two halves together, plus the probability that Z is between 0 and 1.25. So let's use our chart to figure that out. 0.31 right here, there's 0.31. So 0.3 and 1, so that's 0.1217. So that's equal to 0.1217 plus 1.25, 1.2 and 5. Where are we here? 0.3944. Okay, and add those together, 0.1217 plus 0.3944. I get 0.5161. So we have the probability that, and I'm just going to skip this step, you know that this is equal to this, so the probability that x is between 25 and 30, or this is going to be equal to 0.5161, or 51.6%. So the majority that what we're seeing is that the majority of people who are caught drinking and driving by these police are between 25 and 30. And you know what? What you should be doing at the end of these questions typically is you like to write a sentence out. So I'm just going to do it for one. It's kind of annoying for every single one of them, but just understand that you're going to want to include those. There is a 51.61% chance that a driver pulled over for drunk driving is between 25 and 30. Okay. Hope that makes sense for tonight, for this evening. Hope you have a good one. Take care.